Good afternoon, everybody. So, we are talking about one of the biggest chunks of the curriculum and one of the most important things in the curriculum, and that is geometry. And yeah, we started with this intro to geometry. Now, we did this intro to geometry document, but we didn't do this one, and this one is on polygons, and we're gonna do this one today. This video, though, contains both documents. So today what we're going to be doing is we're going to be taking a look at polygons, but before we take a look at that, we are going to do this angle properties. So the first hour will be this angle properties. These questions is the first hour. And we're going to tackle as many of these questions as we can, and then we will tackle this. This is the document that we were looking at last time. We talked about a point, and we started geometry from the very beginning, the ABCs. We talked about a line. We talked about a line segment between 2 points. A ray is from a point outward. And then we started to talk about angles, and you can see here that we have these links here, and if you click these links, you're gonna get things to play with. Like you can see, we have the acute angle, which is less than 90, and as soon as up to like 89 is the acute angle, and then as we hit 90, it's a right angle, and anything above 90 gives us an obtuse angle until we hit 180 degrees, and that is our straight line angle. And then once we go above 180, we have our reflex angle, and that reflex angle is going all the way to 360 degrees, and 360 degrees is the full circle. That is as much angle as you could get. Right? So you could click those things here, like we could click this one here, and we could see if we could read a protractor. And somebody tell me quick, where's the angle on that? I guess this is gonna be a long class today. 50 degrees, thank you very much. What about this one? If I press random here, how much is that? 160. So if the line reach all the way over here, this is 160. It reach 165, 166. What about this one? How do we do this one? Well, first of all, you can see it's at the center there, and the angle is all the way around and going past our protractor, right? So what we could do is say, well, all right, this is 180. So, all right, that is 180, no problem. So it'll be 180 plus this little piece down here. Yeah, because anything on this straight line is 180. So we have 180 plus this little piece. So I'll move the protractor over so maybe. How are we going to measure that for real, boy? 180 plus that. All right, so this is the 180. Well, I guess we would have to draw a line. If we had this on a page, we would have to draw a line here to mark 180, but it have no lines there. So how do I do this one? Or I could come across here. Yep, that's how I do it. So it's an upside down kind of thing now. So I know that this half here is 180, right? So now I'm gonna measure this little section here, and that is this line coming here. So anybody could tell me.
137.
No, not 137.
Oh shit!
Just now.
I forget to add it.
All right. No. I don't want the plus 180. I just want what you see in here on this little piece here, because this line here is the 180 degrees. That is the 180 degrees. I want you to tell me what is from this line coming up here. This one. What is this angle here? This little piece. Right, yeah, because if I'm measuring from here, I'll use this 0. 10, 20, 30, 35, 6, 7. It looked like about 37. So 180 plus 37, and this is 217 degrees. So you see, with a protractor, you could be met with some situations, eh? You could be met with some situations. How much is this one?
121.
About 121. Right, let me see if we get, ooh, we'll look this one. Well, nah, I ain't going through that. I'm not going through that. I had looked it. It's just a review, right? We are going to look at the bus we had one time, yeah? Right? And we can see here the full revolution is 360. You know, we have clockwise and anti-clockwise. And remember these, you see these guys here? From this till the end of the document is pretty much, I would say, the most important. Well, apart from algebra, is the most important part of the equation. You see how if you don't know algebra, you're not passing this exam, right? If you don't know these rules here, you're not passing this exam. You'll have half of your paper too depends on these following rules. Yeah, and of course you have a right angle. Just what is a right angle? And the symbol for a right angle being this little symbol here. And then we have the straight line angle, 180 degrees, an acute angle, an obtuse angle greater than 90, a reflex angle, yeah, greater than 180. Complementary angles add up to 90. Please know that. Please know that. Supplementary angles add up to 180. They share the same side. Adjacent angles share the same side. Once they share the same side, they are adjacent. So these are the things you have to know. Vertically opposite angles, once you see any kind of X, you're dealing with vertically opposite angles. They are not adjacent. They do not share a side. Vertically opposite angles there. You can see A and D here. Angles around a point is 360. And as I said, this does not have to be an X. It could be any weird looking thing where you're required to measure the full amount of angles. We will see examples just now. You have the parallel lines. You have to know these parallel lines. Test time. Test time. Here's what, right? I have A. I'm gonna do this fast. We have two parallel lines. We have the transversal, and I have these two here. Right. B. I have the two parallel lines. I have the transversal, and I have these two here. And C. I have the two parallel lines. I have the transversal, and I have these two here. I want to know, you have A, B, and C. What kind of angles are represented by A, B, and C? A is corresponding, right? And Jahim, what does corresponding mean? What is the relationship that A have to be here? Are they equal? Are they supplementary? Are they complementary? What was the relationship between A and B here?
Complementary, sir.
Nah, they're equal. Corresponding angles. Remember, if you look at it, remember parallel lines are, you can treat parallel lines like the same line. And so this A is the angle above the parallel line. This B is also above the parallel line. So they're the same angle. Japhet says supplementary. Nope. But nice try. Part B. No, but nice try. As I said, these rules are so important, man. Yeah, these rules here, they're so important. What kind of angles are part B?
Corresponding.
Well, these are corresponding over here. Part A is corresponding. These are alternate. And what is the thing about alternate angles? A and B. Alternate angles involve the Z, where you have A and B over here. And remember, A is equal to B here. So these angles are equal. For alternate angles, you also have these angles being equal. The angles that are outside of the Z, right? And can anybody give me part C? Yes, thank you, Josiah.
Is it alternate?
No, these are alternate. Alternate have to do with the Z, right? You notice that corresponding angles corresponding angles are on the same side.
It's on the same side.
But with alternate angles is the only ones that are on different sides of the transversal. So where's part C then?
Is it corresponding?
No, this is corresponding. It has some people that bust the mark already. Deja bust the mark already. Josiah
Interior?
bust the mark. Yes, they are interior. But what do you know about interior angles? Interior angles are when they are inside of this rectangular shape here.
Yeah.
Right? Then that means they are interior. What do you know about interior angles? What's the relationship with A and B here?
They kind of someone.
I don't know what you're saying. You can see the relationship with corresponding angles is that they were equal. The relationship with alternate angles is that they are equal. Right? A is equal to B. A is equal to B. But what's the relationship with interior angles now? Anybody? The relationship with interior angles, Victoriel.
The relationship of interior angles A plus B is equal to 180.
And what's the magic word there?
And
Straight lines?
with what?
What is the magic word? Victoriel.
Supplementary.
Yes.
Oh.
But something else that I noticed that is a help now with this, with interior, is if you look at alternate as well. Because if this B on the bottom is the same thing as the one on the top of the right part of the C, then now the part that is the A in C would be something plus the
180.
original B, which would be 180. So that is make me think about 180.
Oh,
that
okay.
would make 180.
Yeah, well, of course you'll have to employ all of these, right? Because you know that, if you really, and what she's saying is true, if you really think about it, this is a straight line. So that means that this A plus this green angle is 180. But because of alternate, this green angle is the same as this green angle. So that means that this plus this will give you 180. And so that's why, that's a very good observation there of that is why, because of the straight line angle, is why these two give you 180 degrees. Now, I'll tell you something straight up. Let me see. All right. No, well, this is a cheat sheet of everything. This is a cheat sheet of everything. But this is things we do yet. Yeah, but this is pretty much what the cheat sheet of everything looks like. Yeah, and not just you, Nikolai, everybody, right? I'll tell you all straight up that if you do not know this, you will fail the exam, because half of your paper 2 requires this knowledge. Half of your paper 1 requires this knowledge. You don't know this, you're failing. Just like how if you don't know algebra, you're failing. Well, you don't know these rules here, corresponding, alternate, interior. You don't know the difference between those things. You're gonna lose real marks, because you're gonna have at least 2 big mark questions that gonna require you to know that. So don't make joke with that at all. Right? We have these questions here, and we did a couple of them So we're gonna finish off the rest of them. It's up to you how fast this class going. So here what? I gonna call a name and you gonna tell me the answer as fast as you can. Just say the first thing on your mind, don't think about it, right? The type of angles here, they're either complementary, they're supplementary, they're vertically opposite, or the adjacent, right? So I gonna call a name and as fast as you can, you just blurt out one of them. Complementary, supplementary, vertically opposite, or adjacent, right? Shanisha, number 3.
Complementary.
All right, so no, it's not complementary, and that's good. We gain them wrong. These are the questions we can get wrong. Remember, I tell you, blurt out the first thing on your mind, right? The point here is speed, right? So it's not complementary. Why? Because complementary has to do with right angles and the two angles that add up to a right angle. So this have no indication of being a right angle, right? So it's not complementary at all. That's fine though. Japhet, number 3, first thing, quick. Nah, not vertically opposite, right? So we eliminate those things. Vertically opposite has to do with an X and this angle here being equal to this one, right? So no, not vertically opposite. Yes, Josiah, what it is?
Adjusted.
Right, adjacent. Is that what you meant to say?
Adjacent, my bad,
Yes,
sir.
no problem.
My bad.
Right, it is a very weird looking word. Right, I'll give you that. Adjacent is what it is. It doesn't have any particularly knowledgeable features. We don't know the relationship between A and B. All we know is that they share this side. That is all we know. And if they share a side, they're adjacent. Right? So it's not complementary, it wasn't vertically opposite, but they are adjacent, right? What about number 2? Real quick. Anybody? Fast.
Still, is it adjacent?
They are also adjacent, yes. And you should write down these examples and these questions, right? Yeah. I hope that you will. I will leave them here for you to write down. Yeah. And of course you should draw the diagrams as neatly as you can, but don't take too long. Don't be taking forever. Draw them freehand if you could draw straight lines freehand, you know. Number 5, anybody real quick, or do I need to vertically opposite? Very good. And what does that mean? Vertically opposite means what about A and B?
They equal.
A is equal to B. Very good. Real quick, number 6.
That would be the hand, because this one's a weird one.
Yeah, it wasn't. It is a weird one.
I had.
Don't think too
6,
much.
right?
Don't think too much.
Adjacent.
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 Yes, adjacent is correct. Alright. Now, some of you all might think that it looking like a right angle-ish, but it have no indication that there's a right angle there. Remember, for it to be a right angle, you should be seeing this symbol, like how you have this symbol over here to show you there's a right angle. Yeah. So so it didn't have that symbol, so therefore do not assume that that is 90 degrees, because that could be 91 degrees or it could be 89 degrees. Yeah. So so no, it's not complementary. It certainly is not supplementary. It's not vertically opposite. They are just adjacent. They're just next to each other. This angle and this angle, they both share this side. Number 7. No, Jovan. Try again. Yes, Jovan, you're not wrong. They are adjacent. Yes, they are adjacent because they do share this side. So yes, they are adjacent. You're not wrong. But that is not the answer I was going for here. It have a different answer. Sorry, say that again, Karen. Supplementary is correct. What do we know about supplementary angles? Add up to 180 degrees. So we have supplementary. And that means A plus B adds up to 180. If we notice, Jovan, this is a straight line. So that means that this angle and this angle gonna add up to 180, right? Just let me get some donuts for this, and then we're moving on to the next set. Did anybody actually do these questions, though? All right. Very good, Deja.
Yeah.
Very good, Victoria.
So why do I can't I do it right before class in the tablet so that I have it right here on the side of the screen.
I did it.
That's great. Thank you very much, Chevelle. I was hoping that you did it. And fellas, none of all your fellas do it. Josiah, you didn't do it. Yeah, no. All you're robbing all yourself of the opportunity to be wrong. You are saving your mistakes for the exam. Right, so we have this here now. And I'm putting you all through.
Number 8.
Huh?
Number 8.
We did number 8 last time.
Okay.
Number 8 we did in class last time. In the last class. Those are vertically opposite and they're equal. Yeah. But these guys here, yeah. So the people who did it could help me to move this class along. What did you guys get for part B here? For 9B, this angle B.
130.
130. And why? Because
So straight line.
right, they are supplementary. That means that 50 plus B will be 180. So B gonna be 130. Right. What about number 10?
43
43. And what kind of angles are they?
due to the vertically opposite.
Very good. And vertically opposite angles are equal. So B equals 43. Number 11. B.
55.
55. All you get that? Right. These are, what kind of angles are these?
Angles as of nice.
Angles around a point. Around a point. It's around the point. So that means that B plus 209 plus 96. 209 plus 96 plus B is going to be equal to 360. So 209 plus 96 is 305. So B is equal to B plus 305 is equal to 360. So B is 360 minus 305, which is indeed 55. Part 12. Oh, by the way, these are angles around a point. Now, you see how I am always writing what the angle is? I'm not just working it out and giving you the answer. I am always writing what the angle is. I am always writing the reason why. Right? Why did I add all of these? Why did I just add them just out of a VAPS? Yeah. No, I didn't add them out of a VAPS. I added them. This is the reason why. Why did I add this to give me 180? Why? Was it just another VAPS? No, it's because they are supplementary. You must give the reason or you will lose marks. You will get marks for the reason. So where's the reason for number 12?
Right angle.
Oh, it have a C word.
A complementary angle.
Thank you. Complementary. Complementary angles add up to 180.
90.
They add up to 90 degrees. What is 90 minus 63?
27.
27.
27.
Thank you very much. And of course, we do have some. So, I mean, we'll skip these because these are pretty much the same kind of thing. And I will just actually do them real fast. You will see here that this is a straight line. So that means that this is a straight line angle, which means it's supplementary. which means that B plus 35 is 180. What does B work out to be here? 145. Any questions on it? Fellas, I hope all you're seeing this. You can see that I have number 14 here, and this is the right angle. So I want to find these two, and these two here are complementary. Right? Once you have a right angle involved, B plus 29 is 90. So B is gonna be
61.
Thank you very much, Jabari. I appreciate the participation. Somebody work out this one for me. Right? This is angles around the point. And angles around the point, we're dealing with B plus the 243 plus 94, all adding up to give you 360. This plus this plus this.
I got B is equal to 23.
23, yeah. This one here is a straight line, so it'll be supplementary. Supplementary means that B plus 49 is 180. So what is B here?
131.
It's 131.
31.
Yes. And I am recording this class, by the way, because I do not have a video with the corrections of this. So I am recording this class, and this class today, like how all of the other classes were pre-recorded, it does have some classes that I do have to record live, and so yeah, this class today might take a couple days for it to be uploaded, right? We could see here that number 17.
Excuse me, sir.
Yes.
Yeah, let's go to 14.
No problem. No problem. In fact, I'll just expand, right? And from the expansion here, and I hope it's not too small. If it's too small, let me know, right? Because I know some of you all on phones. So if it's too small, let me know, yeah? And I also know that my writing is not the best. It have an X here. So that means this is vertically opposite. You see these questions is gold. These questions is gold, right? If you understand and could do these questions, man, you're putting yourself in a good position, right? That means B is equal to 90 degrees. Same thing here. Vertically opposite. And that means B is equal to 73. Here you can see we have a similar situation, but this time we had to find for X. We're not finding the angle there. We had to find for X. And so I could see here that this is a straight line. It is supplementary, right? So if this is 93, then this side is going to be 180 minus 93. So this side is going to be equal to 87. That means that this is 87 degrees. That means that 3x plus 18 is equal to 87. Yeah. So 3x is going to be 87 minus 18. 3x is going to be minus 18 is 69. And then x will be 69 on 3, which I believe is 23. This is not 23 degrees. The angle is not 23. The angle is 87. We're just finding what x is. X is just a part of the angle. And this, oh gosh, look at straight line. So if this is a straight line, and no, what am I saying? Nobody correct me there. Where's this?
Angles around the point.
Thank you. Angles. Oh, I'm trying to write with Irisa. Angles around a point. So that means that this plus this plus this is 360. So if I want to find this, it'll be 360 minus the 29 plus the 296. So 29 plus 296 is what? No, 29 plus 296 is 325. So 360 minus 325 means inside of here is 35 degrees. So because inside of here is 35 degrees, means that x minus 24 is going to be 35. Right? X is going to be 35 plus 24, 59. And we're just going on with it for the sake of time. I could see here that these are vertically opposite. That means that this is equal to this. So therefore, 2 plus 3x is going to be equal to 62. 3x is 62 minus 2. 3x is 60. X is 60 divided by 3. X is going to be 20. Let me know if I get any of them wrong.
Left 20.
Yes, thank you. And of course, we could see here that this is 90. And this is a straight line. And we know that 290 degrees just give us a straight line. So that means this has to be 90, right? So those two angles that we have here, this plus this will give us 90. So this here will be 90 minus 40, which is 50. So this is complementary. Therefore, 6x plus 2 is going to be equal to 50. 6x is 50 minus 2. 6x is 48. X is 48 divided by 6, which is 8. So these questions are so important because number one, you're practicing, you're getting to know all of your rules, supplementary, vertically opposite, complementary angles around the point. Trust me, the reason why I'm ponging this in all your head right now is because these are not all the rules, you know. It's gonna have some more rules we're gonna have to learn today and tomorrow and the next day. It's real rules. So you see how we learn these first angle properties here? Let me solidify them in our mind. Make sure you know the difference. Make sure you understand them. Make sure you remember them. All right. Well, look, we have these guys here. Right, look it here. Look it here. Let me see all you now. Jediah, what kind of angles are these, sir? Yeah, this one. What kind of angles are those? No, they are not alternate, but nice try. Yeah, nice try. Anybody, what kind of angles are these? Corresponding.
Corresponding angles.
Corresponding angles. Notice, Jediah, that they are both on the same side of the transversal, first of all, but they are both in the same place. This is underneath the parallel line. This is underneath the parallel line. So they are both the same angle. Corresponding. Corresponding angles are equal. So that angle is 130 degrees. Part 2. What kind of angles are those?
Is it interior angle?
Interior angles.
Alternate.
Yes. Interior angles will be inside of the rectangle.
Oh, inside. Okay.
So that means that they'll be on the same side of the transversal. Right? These are on different sides. If you notice the Z here. Now, usually the inside is what you just think about to be alternate, but the outside of the Z is also alternate.
Okay.
Right? So just remember, look out for the Z and it's inside and outside the Z. So these are alternate angles, and that means alternate angles are equal. So this is also 128 degrees. What about this?
So is it alternate? I mean,
Well, it's not one type of angle. You might need more than one to find what that angle is. Because check it out, right? This is corresponding with this, right?
Yes.
Right, so that's corresponding. And then this is vertically opposite.
Vertically opposite. So corresponding and vertically opposite.
Yeah.
Okay.
So you might need to combine your reasoning, right? And so this is 66 degrees as well. What about number 4? Fellas, yeah.
Interior
Yes, they are interior, and interior angles,
is inside.
yes, are inside. And what do we know about interior? And it's really co-interior is what they are called, eh? Co-interior, yes. And so co-interior angles add up to 180.
180.
Yes, they are supplementary. And therefore this angle is 100 if that one is 80. Araya, what kind of angles is number 5?
Right angle.
Well, it sure is that this is a right angle, yes, but where's the relationship between this one and this one? If I have 2 parallel lines and a transversal, and it's just like this. Remember, we had 3 types, and we had corresponding, we had co-interior, and we had alternate. So which one of these is this? Do you know, Araya?
Co-interior.
Co-interior, that is correct. Araya, you get me frightened there for a minute. I feel I had to call your name a little bit more. Right? Co-interior angles are supplementary. That means they add up to 180. So that means if this is 90, this will have to be 90 as well in order to add up to 180. Victoria, where's number 6?
I had 81 due to corresponding angles.
Corresponding angles. They are in the same place with respect to that, the parallel lines. So they are equal. This is 81 degrees. I hope you all are writing them down and drawing the diagrams. This one looks a bit tricky, but don't let those lines confuse you. Where's this one? What kind of angles are these? This one here and this one here.
Wait, let me get back my thinking process.
Don't let the diagram chain you up. It's saying here, and I'll make it easier for you just now, that this line is parallel with this line. These two are the parallel lines. These are corresponding angles. Corresponding angles, you see this line here? Forget about this line here. That line don't even matter, right? This, the 2 red lines are your parallel lines, and this is your transversal. Notice this is underneath the parallel line, and this is also underneath the parallel line. So they are both in the same place. So therefore, this is also 53 degrees. This other line here played no role whatsoever. So things could get a little bit tricky, and I have to admit, all you're worrying me. Yusuf, you could give me number 8.
Would this only also be corresponding?
No, it will not be corresponding. Corresponding is if they were in the same position. So you see, like this, how this is just now, how this is on top of the parallel line. That means that this would be corresponding on top of the parallel line. This would be corresponding on top of the parallel line. Nice try. What you was gonna say again? It is alternate. Very good. If you notice, this line is parallel with this line. This middle line not playing a role at all, right? And if you notice, the transversal is forming a Z. Wow. I had like 3 students just, as like 3 earlier just exited the class just now. Are they hearing me properly?
Yes, sir. I wouldn't
Yeah.
actually
Something wrong with my laptop.
and then it just came off.
So wait, all four earlier had technical malfunctions at the exact same
So
time?
my thing just randomly
Apparently.
freeze.
Where is it, Josiah?
My thing just randomly freeze.
So is have a ghost in the machine? All four earlier had technical difficulties at the exact same time. That's quite interesting. Yes, what we were.
Sir,
Uh-huh.
So I think it's. Oh, never mind. You're right.
Well, is this the answer you was gonna say?
Yeah.
All right, that's great. And I have to say, Josiah, you've been representing, sir. Keep that up. Yeah, keep that up. That is great stuff I've been getting from you. Yes, it is alternate. Alternate angles are inside of a Z. This here is co-interior, because you can see it is inside of the rectangular shape. So that means that this will be 50, because co-interior angles are supplementary, right? This here, what are these two angles? They are also co-interior, because if you notice, this here is on an inside shape like this, and of course this line here doesn't mean anything. So this means that this here will be 180 minus 117, 63. And you guys should be writing this and drawing the diagrams. If we look at the bottom here, we have a solve for x situation. Find the value of x that makes the line u and v parallel. If, then the reason why they word it like that is that only if the lines are parallel would these two angles here be alternate angles. If the lines are not parallel, well then they're not alternate angles, right? So this here is alternate angles. Alternate angles are equal, so that means 16x minus 6 is 90. 16x is 96. X is 96 divided by 16. In this case, we could see that the two parallel lines, this is on the bottom of the line, this is also on the bottom of the line. They are both in the same place, so they are corresponding. Corresponding means that they are equal. So 12x minus 4 is equal to 10x plus 10. I could throw the 10x on this side and the minus 4 on that side. So I'll have 12x minus 10x on this side, and I'll have 10 plus 4 on that side. So that'll give me 2x is equal to 14. X is 7. It's only when x is 7, right, that the two angles will be the same. Only when x is 7 is when the two angles will be the same, and therefore the lines will be parallel. You can see with this one, this angle A is corresponding with this angle A, and then this angle A is vertically opposite with this angle A. So they are all equal, they are all the same, and so therefore in this case x plus 112 is going to be equal to 105, because this here will be x plus 112 as well, because of corresponding. And then, oops, corresponded. And then this is vertically opposite. So that means that x is gonna be 105 minus 112, which is negative 7. Only when x is negative 7 will they be equal. So you can do corresponding and vertically opposite. Yes, thank you, Joanna. Right. Deja, are you catching on to these questions?
I had the first one correct. The second one that you're doing right now, no, I did not get that correct.
But you're understanding it.
Yes, sir.
That is the only thing that's important. Right? And gentlemen, I hope you all are understanding it as well. This 110 is corresponding with this 110. And this is vertically opposite with this. So therefore, 19x minus 4 is going to be equal to 110. Because they're all going to be equal. So therefore, 19x is going to be 114. X is 114 divided by 19. Did you try the critical thinking questions? Anybody?
I tried one.
All right. Anybody else? I think Victoria bail out on me. Victoria, you're not here anymore? Oh no, look at it.
I
Alright.
didn't do it because
No
I
problem.
did it last week.
That's fine. If we notice here, yes, it's looking complicated, but these are the two parallel lines. These are the two parallel lines. This is the transversal. So notice that these two angles are in the same position. Yeah. Pertaining to the parallel lines. So therefore they will be corresponding. If anybody can't see it, let me know, you know. I'll show you. Minus 2 will be equal to 130. So 11x is 132. X is 132 divided by 11, 12. And of course, these are alternate. You can see the z quite easily. And so, 7x, alternate. And alternate angles are equal. So, I could throw the 7 on this side and throw the 6 on this side. So, I have 14 minus 6 on this side. And I have 8x minus 7x on this side. So that means I have x on this side, and 14 minus 6 is 8. X is equal to 8. Now that means, because you notice it's two different equations, so x needs to be 8 in order for these two equations to be equal. If x is not 8, these two equations would not be equal. If these two equations are not equal, that means that these two angles are not equal. And if these two angles are not equal, it means that these two lines are not parallel. Because that is what makes the lines parallel, the fact that those angles are equal. So for critical thinking, for question 16, you notice they say find a value. They didn't say find the value. Find a value of x that makes lines u and v not intersect. Can anybody give me any value of x that'll make line u and v not intersect?
One.
Yeah, you are correct. Anybody else?
I was thinking 0.
Yeah, you're correct too. Anybody else?
Sir, is it 1?
Yeah, you correct. Anybody else? Yeah. 0 is correct. -5 is correct. 23 is correct. Because you see, when x is 8, that means these two are equal. Right? When x is 8, these two are equal. So that means that, when x is 8, these two are equal. And if these two are equal, the lines are parallel. So if once x is not 8, x could be anything else. Once x is not 8, then these two things will no longer be equal. Remember, 7x plus 14 is only equal to 8x plus 6 if x is 8. If you put x to be 1 inside of here, they're not going to be equal. If you put x to be 2 inside of here, they're not going to be equal. It could be anything. So any other value, right? Even if the lines in question 16 were not parallel, could x ever be 25? No, because 25 will be 7 times 25 plus 14. 25 that is more than a straight line. 189. So that means that if you're measuring this angle will swoop this way and it will end up be like this. So that means that x could never be 25.
But and they said that the lines in question were not parallel.
Yeah,
so
the line.
Just be intersecting them.
Yeah, the lines. Even if the lines were not parallel, but remember, this is supposed to be a straight line. Yeah, this if this angle here was 189, then what would happen to this line is this wouldn't be a straight line anymore, would it? Right? You understand?
No, sir. It would be like an angle.
Yeah, it wouldn't be a straight line anymore. So you wouldn't be dealing with 2 straight lines anymore. Yeah, you'll be dealing with 3 line segments or something like that, you know. So just a little bit of a thinking stuff. All right, let me ask you something. Let's see in this shape here, right? You seeing this shape here? What kind of shape is that? Well, if we look at it here, that is not a square, because I know that, you know, you would naturally think a square because of the 3D perspective. But if you just look at it in a 2D form, that is not a square, right? But what it is some kind of a polygon. And you don't have to write this just yet, right? Don't write it just yet. But essentially, when we started geometry, we started with the dot, right? And then 2 dots, this give you a line, right? And then I have 2 lines that join to give me an angle. And then we started to study the properties of the different angles. You had the complementaries, you had the supplementaries, you had parallel line angles, you had vertically opposite angles, and all sorts of different angles, like angles around a point kind of angles, and reflex angles, and all of them kind of angles. Right? So we started with a dot, 2 dots give us a line, 2 lines give us an angle, and we studied all of the different types of angles. Now we're gonna start to have 3 lines and 4 lines and 5 lines, and all of these kinds of lines, right? Shapes that are made of straight lines, right? Because remember, we just kind of adding on lines to these things, and each one of these shapes will have angle properties of their own. Each one of these shapes will have angle properties that you will have to learn. And so what we're talking about here, we're not getting into the specific shapes just yet. What we're talking about here, we're just going to do a quick overview on polygons. And we're just going to talk about all of the different types of polygons. Now, it is going to have a lot of drawing today. It is all just a general overview of polygons. And then in the next class, we're going to go specific into triangles and quadrilaterals now, right? But this one is generally talking about a polygon is a closed plane figure with straight sides. A closed plane figure with straight sides, right? Even that one that we drew just now that was looking something like this, yeah, that is a polygon, a closed figure with straight sides. It doesn't have to have 4 sides though. It could have any amount of sides once it's straight. A regular polygon is a closed plane figure with straight sides all of the same length. So if you have a square, all sides have the same length. A square is a regular polygon, right? A rectangle is not a regular polygon. Yeah, we can have some types of triangles that are regular polygons, and then we can have some types of triangles that are not regular polygons. So a regular polygon is when all of the sides are the same, and an irregular polygon is when you have different lengths for all of the sides, right? So these are essentially the classes of all of the polygons. Yeah. These are the classes of all of the polygons here. And of course, you know, you don't have to like draw it perfectly. You could just do a little bit of a sketch if you want. And we do have some interesting things. Like we have, and this is, you know, not all. So we have the 3-sided polygons, which are triangles. And these are not all of the different types of triangles. There are many types of triangles. This is just some examples. Yeah. And then we have the 4-sided polygons, which are called quadrilaterals. And of the quadrilaterals, we have 2 types. You can see we have parallelograms. There's one type of quadrilateral. And the other type is the trapezoids or trapezia. And that is plural, by the way. Right? Trapezium is singular. Yeah. And so the parallelograms include those shapes that have sides that are parallel. So this is parallel to this. And this is parallel to this. Once you deal in with a shape that has parallel sides, then all of those parallel angle rules will come into play. We know that the sides of a square are parallel. So this one is parallel to this one here. And this is a rhombus. A rhombus is a square, and as I say, we will learn the details about these things going down the road. But a rhombus is a square that have equal sides, and the sides are parallel, but is not 90 degrees. So if you take a square and you just kind of knock it over a little bit so that the angles are not 90 degrees anymore, you'll get a rhombus, right? And these are the trapezoids. Trapezoids include one pair of parallel lines, and then the other pair are not parallel. And then we have the other polygons, the 5-sided, the 6-sided, the 8-sided. And all of these polygons we will have to learn more about. Joanna, have a question here. What's a circle under? Well, remember, Joanna, all of these we're talking about here are types of polygons. And a polygon is a straight-sided figure. Now, you could think of a circle as being a polygon, because if you notice, the more sides that you add, right, is the more circular the shape becomes. Right? So a person theorized that a circle is a polygon with infinite sides, right? But that is one way to think about it. Another way is that a circle is not a polygon at all because it doesn't have straight sides. It has a curve. So a circle is its own thing, right, Joanna? So I hope that answers your question. Right? Shanisha, where it is? Right. And of course I have a link here. Now we're just talking about real quick the types of triangles, and then we have some polygons here that we'll talk about the types of quadrilaterals as well, and then that should be it. Just some types of triangles and some types of quadrilaterals, right? And of course, in the next class, we will do triangles and quadrilaterals in greater detail. So this is just an overview. But you'll notice if we're looking at the side of a triangle, right? 3 equal sides. This is our regular polygon. It's an equilateral triangle when you have 3 equal sides. And all equilateral triangles have angles of 60 degrees on the inside. All, right? All equilateral triangles carry 360-degree angles. We will see why in the next class. An isosceles triangle, and here now, you have to know this. You see all of them rules I was talking about that you had to know? This is part of it. An isosceles triangle has these 2 sides being equal and the base angles being equal. A scalene triangle, that is the crazy one, it have no equal sides, no equal angles. If we're looking by angle, we have the acute triangle where all of the angles inside are less than 90 degrees. We have the right angle where one of the angles are 90 degrees. And the obtuse triangle is where one of the angles are greater than 90 degrees. All right, let me talk about quadrilaterals now. And I mean, we saw some of this, right? With a quadrilateral, it have, first of all, we have a kite. Now, we're gonna see some of the, like this diagram here. And you don't have to draw all of it, by the way, right? Then it have this diagram here. All of them pretty much tell us the same thing. I think this diagram does the best when it comes to all of the details of each one of them, you know, in a diagrammatic way. Like, you see how this does use words, right? Well, we don't need words in geometry, right? We need symbols in geometry. And this one here has so much information in symbols, but we're gonna look at this one here because this one shows us the hierarchy of quadrilaterals. So this is the hierarchy of the quadrilaterals, and I'll see if I can include a lot of the details in this diagram so that we don't have to draw the other diagrams. But in a kite, this side is equal to this side, and this side is equal to this side in a kite. In a kite, this angle is usually equal to this angle. Yeah. And let me just check something. Yeah. And then in a kite, the diagonals will usually cut at 90 degrees. Now, this is stuff that you should be familiar with, right? I wouldn't say that is one of those detrimental rules that you had to know, right? A trapezoid will just take many shapes and forms, but generally you have these 2 sides being parallel. Now check this out, right? If these 2 sides are parallel, well, that means that this is a transversal, which means that these 2 angles are going to be supplementary. And that means that this is another transversal, which means that these 2 angles are going to be supplementary, right? So you have these 2 angles giving you 180 degrees, right? And then you have these 2 angles giving you 180 degrees in a trapezoid. Yeah. We have the sets of parallelograms now. And a parallelogram is a quadrilateral where, you know, you have the pairs of sides being parallel. So these two pairs of sides are parallel, and these two pairs of sides are also parallel. So that is a parallelogram. Now check this out. I bet you all didn't know this, right? But in terms of the parallelograms, the types of parallelograms, you have a rhombus is a type of parallelogram, and you have a rectangle is a type of parallelogram. Right? In a rhombus, all of the sides are equal. All of the sides are equal. You have this side parallel with this side, and then you have this side parallel with this side. So all of these little symbols here just hold so much information. Missing out anything about the rhombus? Right. All the opposite angles are equal in a rhombus. So in a rhombus, this angle here is equal to this one. And in a rhombus, this angle here is equal to this one. The opposite angles of a rhombus are equal. And the next diagram has all of this information in diagrammatic form. So much information. Okay. The thing is, though, that we have a rectangle here which have parallel sides. And a square is a type of rectangle because a square has all parallels, has two pairs of parallel sides. These two, this is parallel with this, and then this is parallel with this. Yeah, so the parallel sides here, and that is why a square is a rectangle. It's a type of rectangle. But a square is also a type of rhombus, because it is the rhombus that is responsible for all of the sides being equal. All of the sides are equal in a square, so a square is a type of rhombus. And we have this nice little thing here. Do you agree with this? A square is a rectangle. A rectangle is not a square. You all agree with that?
Yes.
Yes, but
Yes.
last time you had taught leaders. I remember when my sister talking about it, and she was like, what you kept talking about? And that was a whole thing. I go bring it back up for she goes, girl.
But you have to be able to explain it to her as to why.
Yeah. I did, but
Yeah. Alright, a square is a rectangle, or a rectangle is not. But a rectangle is not a square. Let me hear Dunnits for this. Now, we do have, just now, because all of the sides of the square equal and all of the sides of the triangles isn't equal. I think you mean rectangle, Joanna. I think you typed triangle, but you meant rectangle. Yeah, Otto. Yeah, I know Otto. But yes, you are correct. Chevelle, you have a question?
So I'm done.
Okay, no problem.
And I'm tired.
Yes. Well, we have these 2 pages to do again, but we're not going to do that today. Don't worry. And then that's the end, right?
Hallelujah.
Yeah, don't worry. We're not going to do that today, but we will take a look at this. You see, this diagram have so much information. So in the next class, what we're going to be doing is, you know, we did a overview of polygons today. You know, we remember we started with the dot, Now we had the line, we had the angle, we had triangles, quadrilaterals, and polygons now is where we reach. So in the next class, we will be doing both the properties of triangles, where we'll be learning all of the triangles and all of the angle laws pertaining to them, and the properties of quadrilaterals as well. Right? So in the next class, we'll be doing triangles and quadrilaterals in great detail. And then in the class after that, we'll be doing polygons in general and the angle properties of polygons in general. Then we'll move on to things like perimeter, area, volume, and then at the end we'll do circle theory. We'll also have to do constructing angles as well. Yeah, so we do have a lot to do with geometry. Deja?
The dashed lines in the kite, is that for holding?
Is that for?
Holding.
What do you mean holding?
Hold.
Fold. Oh, no.
Folding it up.
Yeah, no. These are the
Like triangles.
these are the diagonals.
Oh.
And the
But
point,
they don't look like triangles.
yeah, but the point, yeah, well, of course, because remember, everything is made of triangles, Everything is made of triangles. Everything. When I mean everything, even your thoughts are made of triangles. Even the sound that coming out of my mouth is made of triangles. Even, and you know, like when you're feeling hungry and you're feeling the pain in your stomach, that
Yes.
pain is made of triangles. Right? When you're feeling like you're in love with somebody, that love is made of triangles. Yeah, I'm not joking. We will see why when we do trigonometry. We will see why when we do trigonometry.
Okay.
That is why I tell you earlier, geometry and the trigonometry is the study of God. We are studying God right now. This is what makes up everything. So these, Deja, are the diagonals, and the point here is that in a kite, the diagonals cut at 90 degrees. That is the point there. That is the point that I was making.